Hello, dear students. How are you? I hope you are doing well. Myself, Bhavika, your chemistry mentor. Today, we are going to talk about basics of chemistry. You have finally entered into standard 10th. So, you must be worried about your basics. This is your board year after all. So, you must be worried about your basics. Your basics must be strong in order to enhance your score in 10th, 11th, and 12th. So, keeping this in mind, we have started a series called Back to Basics. Back to Basics. Okay, in which we are going to study about the basic topics of physics, chemistry, maths and bio. So today we will study a very basic and very important topic of chemistry, and that is, as you can see, valency. Okay, as you can see, valency. Valency is very important topic of your chemistry, because if you know the valency of any element, then it gets very easier for you. Okay, it gets very easier for you to predict its physical chemical properties. Okay, mostly chemical properties. So in order to understand, in order to learn the valencies, we must know the atomic number of elements. So, one thing I'm keeping in mind, I'm just assuming that you must know, okay, you must know the atomic numbers of element of from 1 to 20. Okay, so I hope you have learnt it, the atomic numbers from 1 to 20. If you have not, then please do it. You must know it. Okay, till 20. Okay, I'm not telling you to learn more, but till 20 you must know it, because if you know atomic number, then you can understand, you can write its electronic configuration. If you know its electronic configuration, then you can predict its valency, and if you can predict its valency, then you can know its chemical properties. You can know its exact location in periodic table. You will say, ma'am, how it is possible? I will teach you. Don't worry. Let us get started. So, first thing first, what is valency? We have learned how the electrons, okay, how the electrons in an atom are arranged in the different shell or orbits. Can you tell me which law or which rule suggests that how electrons are placed in orbits? Do you know anything for that? Do you know any rule, or is there any formula like how many electrons can accommodate in that particular shell? Do you know? Yes, you know. Niels Bohr. Yes, Niels Bohr was a scientist. He gave his atomic model, and he also talked about a rule. And which is that rule? That rule is 2n square. Yes or no? Yes, ma'am. 2n square is the rule where what is n? N is the number of shell. Okay, which shell it is placed in. Okay, we know there are 4 principal orbits, that are 4 principal shells, and that are K, L, M and N. Okay, so if I tell you to write its number for K, N is what? N is 1. For L, N is 2. For M, N is 3. And for N, N is 4. For capital N, small n is 4. So if you put these values, okay, if you put these values in 2n square formula, what you get? You will get 2 into 1 square is how many electrons? 2 electrons. Yes. For n is equal to 2, 2 into 2 square is 4. So that is 4 into 2 is 8. 8 electrons. For M, 2 into 3 is square, that is 9. 9 2s are 18 electrons. And for N, 2 into 4 square, that is 16. 16 2s are 32. So that's how we can say the number of electrons which could be accommodated in a particular shell. Right? Clear till here? So the electrons present in the outermost orbit. Okay. So here what we are concerned is, we are only concerned, if you are talking about valency, then you are only concerned about which shell? Outermost shell of an atom. Never ever forget that whenever I am talking about valency, whenever I am talking about valence shell electrons, I am always talking about outermost orbit of that atom. Okay, when you are talking about valency, the innermost orbit do not play any role. Okay, you must be thinking that what is innermost, what is outermost. So let us learn that with an example. See, let me draw an atom for you. This is the nucleus. This is its first orbit. This is second. And this is third. Okay. For example, if you are talking about chlorine atom, what is the atomic number of chlorine? Do you know? What is the atomic number of chlorine? It is 17, right? 17, which means what will be its electronic configuration? What will be its electronic configuration? 2, 8, 7. Yes or no? It will be what? 2, 8, 7. So now we will put those electrons over here. See, this is proton and neutron. Okay, fine. So this is 1 here, 2 electron here. Okay, first shell done. Now come to second shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, second shell also done. Then third consists of 7 electrons. 1, 2, 3, 4, 5, 6 and 7. So if I ask you, okay, let me ask you, if I ask you which are the innermost shell, okay, if I ask you which is the innermost orbitals, then what you will tell? Innermost orbitals are this and this. So this is your K shell, L shell, M shell. So here in this particular atom, the innermost orbital is which one? They are K and L shell. But if you talk about outermost orbit, okay, if you talk about outermost orbit, then which is the outermost orbit? M shell. Okay, M. So we are just concerned, okay, this thing if we will not talk about when you are talking about valency. When we are talking about valency, we will just talk about outermost orbit. Okay, you can alternatively also call it as valence shell. Okay, you may find this word in many books, valence shell. So don't get confused. Outermost orbit means valence shell. The both terms are same. Okay, so do not get confused. If you talk about valence electrons, okay, if we talk about valence electrons, then what are valence electrons? Very simple. What are valence electrons? The electrons present in outermost orbit. Okay, the electrons present in outermost orbit is termed as valence electron. All here, how many valence electrons are there? Here total 7. Okay, chlorine has, for example, you can write over here, chlorine has 7 valence electrons. Clear? See, till here I have just talked about valence shell and valence electrons. I am not talking about valency. That we will talk further. Okay, so just do not get confused between valency or valence shell or valence electrons. They everything are different. Okay, valency is not is not a number of valence electrons. Okay, many students misunderstood the concept and they think that valence electrons is valency, number of valence electrons is valency, that what they think, but that is not the case. So just be sure, be clear. Okay, so now let us go to our first slide. So they are talking about here valence electrons, the electrons present in the outermost shell. Okay, clear till here? Now what is valency? Now we will talk about valency. Okay, please listen carefully. Valency is the combining capacity of an atom. Combining capacity? What does that mean? Like how a atom, okay, how an element gets combined to other, okay, and how many electrons are gained or lost, that is combining capacity. Still not clear? Let us see it in detail. See, from the Bohr-Bury scheme, a Bohr-Bury scheme you must have studied in 9th. We also know that outermost shell of an atom can accommodate maximum of how many electrons? Maximum of 8 electrons. And this is rule is which rule? This rule is octet rule. Yes? But for first orbit, okay, we have an exception over here. And what is the exception? For first orbit, it can accommodate only how many electrons? 2 electrons, and that rule is your duplet rule. Okay, let me repeat it. Okay, see, for first orbit, if your electrons is in first orbit can only accommodate 2 electrons, that we have seen from that 2n square rule also. Okay, so the capacity of first orbit is just 2 electrons, right? It can only accommodate 2 electrons. But for rest of the orbits, for all the orbits after 1, they can accommodate maximum up to 8 electrons. What that mean? That means, now you must be wondering, why 8? What is so special about 8? So here we have an octet rule which says that if a shell attains 8 electrons, it becomes stable. Okay, it is experimentally found that the 8 electrons of orbits give stability to that atom. Okay, so 8 is associated with stability over here. So if an outermost shell contain 8 electrons, then it is stable. So now you can think, now you can know that why helium, neon, argon, krypton, why they are called noble gases. Okay, you must have heard of it. And if you have not, then please listen it again. Helium, neon, krypton, argon, xenon, they all are very stable gases, and thus they are not non-reactive in nature. They do not react, they are very stable, and they are known as noble or inert gases. Why so? Because the reason lies in the same, the octet rule. They already have 8 electrons, and if you have already 8 electrons in your outermost orbit, then there is no need to react. Okay, you are already stable. Yes or no? See, for example, I am offering you some food. Okay, but if you have already took your lunch, dinner, if you have already had your meal, then will you accept my offerings? Of course not, because you're already done. There is no space in your stomach for more food. So what you will say? You will say, no, I don't want to eat. I already had my lunch or dinner, whatever. But if you are hungry, okay, if you are hungry and I am offering you something, then you will eat it because you are hungry. The same logic goes over here, that if an orbit does not have 8 electrons, it has less than 8 electrons, then that orbit is hungry, and in chemistry language it is unstable. So what will do? See, it is very simple, that every single thing in this universe is trying to attain what? Attain stability. Okay, either you or me or any atom, any element, anything, what they are trying to do? They are trying to attain stability. Everybody wants to be stable. So if they do not have 8 electrons, they will try to attain 8 electrons. How they will try? That is a good question. Okay, ma'am, we have understood that if they do not have 8, they will try to attain that 8 magical number. But how? That is a very good question. How they will attain? So the answer is by gaining or losing the electrons. Either they will accept electrons or either they will lose electrons, and that's how they will attain stability, and the number of electrons gained or lost. Okay, I'm repeating, the number of electrons gain or lose, that is valency. Yes or no? That particular thing is valency. Okay, so valence electrons is not valency. Now you will ask, ma'am, okay, number of electrons gained or lost, that is valency. But how we will come to know that that particular atom will accept or lose? Who will tell us? Atom will not come and tell you, na, that today I'm in mood to lose electrons, so please take away my electrons. No, no, no. Today I'm in mood to accept electrons. Please give me some electrons. It does not work like that, right? So what? How that they will decide? How they will decide that how to lose or how to gain? Okay, how they will decide? So let us just see how they will decide. Let me take an example of let us take an atom. This is its first orbit, this is its second. Okay, this is again I'm taking another atom. This is its first orbit and this is second. Okay, see, if we are talking about magnesium, yes, magnesium, what is the atomic number of magnesium? It is 12, right? Yes ma'am, it is 12. So what will be its electronic configuration? 2 8 2. Okay, we need one more orbit. Yes, we need one more orbit. So let us draw here. 1 2 1 2 3 4 5 6 7 8 electrons, and in outermost orbit 1 and 2. Okay, 1 2. So now let us assume, okay, what will calcium do? Calcium have two options. Sorry, not calcium, magnesium. Magnesium have two options to attain stability. Can you name them? Which two options have magnesium have? Either it can lose 2 electrons. What it can do? It can lose 2 electrons, or it can gain how many electrons? 6 electrons. See how? If it will lose 2 electrons, this will become 2 8. 8 is attained. Okay, stable. Yes, that way it can be stable. Or if it is gaining 6, 2 plus 6 is 8. 2 8 8. Yes, stable. So in both the ways it can attain stability. Now the question is, what magnesium will do? It is clearly seen here, beta. It is clearly seen which is the easier way to attain stability. See, as a human being, what we do? We find shortcuts, right? To accomplish our work, what we do? We try to find shortcuts. Yes? Yes or no? We try to find shortcuts. What is the shortest way to do this thing? Same goes over here. Atoms also try to find shortest way to complete their work to attain stability. So in this too, what you think which is a shorter way to, which is a shortcut method? Of course this one. It is easier to lose 2 electrons than to gain 6. Agree or not? Yes or no? Yes ma'am. Of course, it is easier to lose 2 electrons than to gain 6. So what will be its valency? Its valency will be 2. If you talk about valence electrons, is 2. Okay, chalo. Now let us talk about another example. Now let us talk about sulfur. Yes, let us talk about sulfur. Sulfur is 16, that is 2 8 6. Okay, 1 2 2 3 4 5 6 7 8, and 1 2 3 4 5 6. Okay, now we will see again what happens. Sulfur has two ways. What are the two ways? It can either lose 6 electrons, okay, that way it can also attain stability, or it can gain 2 electrons. Okay, it can gain 2 electrons and attain stability. So now tell me which one is an easier way? Which is easier? Of course, gaining 2 electrons is an easier way. Yes or no? Yes, ma'am. Gaining is an easier way because it just have to gain 2 electrons. But for losing, it has to lose 6 electrons, which is relatively tougher. Yes. So what happens? This is the way preferred by sulfur. Its valency is 2. Yes, because gaining 2 electrons, its valency is 2. But what are the number of valence electron? Valence electron would be 6. See, I told you na, always valency and valence electrons cannot be same. Okay, so that is the thing. You will just see that which is the shortcut way. Okay, for any atom you just have to think which is the shortcut way for it to attain stability. Okay, it was observed that the atoms of elements compounds filled with 8 electrons in the outermost orbit shell show little chemical activity. So here are the different shells given to you. Okay, so if you talk about lithium, has got 1 electron, so it is easier to lose 1, so its valency would be 1. For beryllium it will be 2. For boron it will be 3. For carbon it will be 4. But for nitrogen, see, nitrogen has 5 electrons outside. So it is easier to lose 5 electrons, or is it easier to gain 3 electrons? You will say it is easier to gain 3. So its valency will be 3. Oxygen will be 2. Fluorine would be 1 and neon would be 0. Why 0? I told you now, already 8 electrons, already stable. Okay, your stomach is already filled. You're already satisfied. Then why you will eat more? Yes, getting my point or not? So that's how you can tell the valency of, you can predict the valency of any atom, but provided you must know its atomic number. Okay, if you know its atomic number, you can write its electronic configuration and then you can predict its valency. So here is the table that is given in your textbook. Okay, in your NCERT textbook, it says the elements from 1 to 18 elements are given to you. This shows the distribution of electrons and this shows the valency. Okay, these are the particular symbol is given to you. You can see 1 0 1 2 3 4, then 4, then the number is again dropping. From 4 it is going to 3 2 1 0, then 0 it is again going 1 2 3 4. Okay, yes or no? Clear? You can say, okay, from this you can write a note. Okay, you can write a note that is, if outermost orbit electrons are 1 2 3 4, then the valency would be equal to outermost orbit electrons. Okay, if the valence electrons or the outermost electron is 1 2 3 4, then valency is equal to outermost orbit electrons. But if outermost orbit electrons are 5 6 or 7, okay, or 8, what you have to do, valency will be equal to 8 minus outermost orbit electron. Okay, that's how you can just summarize this entire lecture, and you can write this note. Okay, it's again a shortcut. See, if you are using the concept, it is well and good. Okay, the concept never ditch you. But this is also a short form. It also just lead to concept what we have learnt. Okay, if there are outermost orbit, if the valence electrons are 1 2 3 4, then the valence is directly 1 2 3 4, because it is easier to lose that many electrons. But if the outermost orbit electrons are 5 6 7 8, then the valence will be 8 minus that, because in that case, in case number 2, it is easier to gain than to lose. Okay, so please write this note. And this is the end of this beautiful lecture. I hope you have understood it. If you have not understood any topic, you just comment in the comment section, and I will just see to it. Okay, take care of yourself, study well, and be happy. Thank you.